Hello everyone. Today we are going to talk about the very basics of MATLAB. First, we talk about the MATLAB Graphical User Interface, or GUI. So when you launch MATLAB on your computer, whatever version, you typically see something like this. Your monitor would show MATLAB GUI. That's by default looks like this. Now sometimes some people will remove some of these different windows, correct? Each one of these windows, if you can see, there is a small triangle. When you click on them, you can close them, you can basically minimize them and so on, or undock or dock, okay? Undock means to make it a floating window and not attached to the rest of it, or you can dock it back to wherever it was. So you see here, I go and say undock, and now my workspace is a separate window that I can move to a second screen or anywhere. And this is good when you want to see that specific window in a larger size. And if not, you want to put it back to where it was, you click and say, okay, dock it back to where it was. And whenever this configuration of these different panels or windows are not what you want and you want to go back to default, or you change it, under the home tab here you go to layout and you can select the 3-column, you can add anything, you can make it to be default, and so on and so forth. Okay, if you want to remove something, you click on it and remove the check mark next to it. So anyways, we'll talk about some of these important windows and some of these important tabs up here. So as you can see, right now there are 3 major tabs. There is Home tab, there is Plots tab, and there is Apps tab. So we start with the Home tab, which is the major tab in MATLAB. And as you can see, there are several areas. Here where I have the cursor blinking, it's called the command window. And this is where you type your command, right? So you can say, for example, what? 3 times 4, and it gives you the answer, correct? Or any other higher level math. I'll show you. You can do lots and tons of operations in MATLAB. Okay, it's one of the best when it comes to research and development. So that's the command window. Now here on this top left, you see the current folder. This is the folder that every file you make will be saved to this folder. And most of the files that you read are directly coming from this folder. Now, it's not the only folder that you can read the stuff from. There are others. We'll talk about it, and we'll talk about changing the current directory and setting path later. But this is the current folder. For example, if I go to my, let's say, downloads, right? And you see the address for it. Right now, it is under C users, my name, and under MATLAB. But if I want to change the folder that I read and write from and to, I click here for browse for folder, and I change it, let's say, to my downloads. Okay, and then you can see everything that is under my downloads, and this address would change. Okay, and now you can do basically everything that is in here. Okay, then you have this bottom left window called Workspace, and Workspace is the window that stores your variables. Okay, right now I only have one variable. That's the variable called ANS, or answer, and the value of it is 12. Okay, and you can always double click on any variable here, and it expands it and show you the Workspace extended, where you can see the size of that variable. It's 1 by 1. The value of it is 12. And here kind of acts like an Excel sheet. So if you want, you can insert rows, columns, you can delete anything, you can basically add variables, correct? You can open a file and import the variables from that file, and so on and so forth, okay? So we'll talk more about this as well. You can even select specific columns of that and do a plot. So this part of it is quite very similar to the Excel, Microsoft Excel. Okay, so and if you want to also know about which variables you have here stored in the Workspace, You can use the command who, okay, and there is also whose. Okay, who shows you the variable, but whose gives you a little bit more info. Not only gives you the name of it, it gives you the size of it, the number of bytes, the class of it, which is double precision, and if there are any attributes. Okay, so if you want to know which variables you have, let's say I have A, which is now 4.3. I have B, which is a complex number, 3 plus 8 times I. And I have C variable, which is a string like hello world, correct, and so on. So now if I say whose, you see I have different variables, double precision, character, the number of bytes, the size, and everything, okay? You see the number that is complex, it says it's double, but it's a complex number. So anyways, this is where your variable is stored. We call it the workspace. Now, the commands that you have used so far, they are in the what we call command history. And if you go to the layout, the command history can be docked, which is added here, or you can basically make close it or have it pop up. Right now it is as pop up. What does it mean? Means if I want to recall one of the previous commands that I used, all I need to do is to use the up and down arrow of the keyboard. So if I click on up, you see the command window appears, pops up, and any command that I used right now or even previously up to some extent, along with the date and time I used those commands, you can see, right? And all I need is now to move my highlights, this gray highlight on that command to recall it, correct? And then simply enter. Or if I want several commands to use at the same time, I can just hold down shift and use up and down arrow to what? To select several of them, correct? And then enter again. Okay, so with up and down arrow, your command history pops up here, as you can see, and you can basically reuse the commands you previously typed here in the command window. Okay, so I guess I talked about these important 3 windows that you have and the command history that right now is pop up. And there are some other stuff here under the Home tab. If you want to create a new file, a new live script, we talk about them. New other types of files like figures, functions, class, and so on and so forth. If you want to open an existing thing, if you want to import data, we'll talk about this import data and save workspace more. You want to create a new variable, you can, or you can simply type the command for it. Okay, if you want to clean up the workspace. So if you want to clean the memory of MATLAB, which is called workspace, one way to do it is to use clear workspace, or you can simply type in the command window clear or clear all. Okay, and that would take care of what for you? All of the variables currently stored in the workspace. Okay, so clear or clear all will take care of that for you. Now you might say, how can I clean up this command window? The command to do is called clear screen or CLC. So once you do that, there we go. The screen is clean. And that's also here, it says clear commands. Okay, we'll talk more later on about analyzing code, run and time, Simulink. I have several videos on Simulink, so you can go and look at them. If you want to add support package, hardware support packages, other adds on, you can do it under here. We'll talk about that in a separate video. There are preferences. For example, maybe you want to increase the font size, right? Maybe this font size is too big or too small for you. You simply go under preferences and then look for the font here, which should be here, and change it to any size, any shape that you want. Let's say I want to make it 36, so it's even bigger, right? Or maybe that's just too much for me, so I go and make it like 20, 18 pixels or whatever. Correct? If you want to change the color of the background, there are all sorts of things that you can do, correct? So here is the command window. There are some options, command history, and this is, as I said, is the color. right? So you can change all sorts of things, change the colors, change the different type of attributes for the colors, like red is error, blue is a keyword, strings are purple. We talk about the meaning of colors, warnings are orange, and so on. Okay, and if you don't want to use the system colors, you can uncheck this. And for example, instead of background that is white and the text that is black, I know some people prefer to type white text over a black background because they probably have done something in C or Python and they would rather do it like that. That's okay, no problem. Okay, so it's up to you to choose your preferences here. I would rather use the black text over white color, but again, feel free to change anything that you want. There is community help, there is Learn MATLAB, and support and help. Help of MATLAB is, I can say, one of the best, if not the best help I have ever seen in the software packages I have used so far. I mean, SolidWorks is relatively good too, but some other software packages, their help are literally non-existent or really horrible. MATLAB is unbelievably good, and the help document of MATLAB is amazing. Each toolbox, each part in MATLAB that you want to learn more about it, you just click on it. Let's say I want to know about processing images. So I go to Image Processing Toolbox, and it tells me everything about it, how to get it started and do stuff. It gives me all sorts of examples. It gives me the list of the functions, the list of the applications for it, and so on. Okay, so if you just want to start learning about it, just go to examples maybe, or go to all and start from get it started, and you're going to see tons of good material. It's really amazing the amount of knowledge you can get. And also you can always go to MathWorks, okay, and the website for MATLAB. It's really amazing, and you can go to MathWorks File Exchange, where there are lots of files about the topics and the functions, the stuff that are not written in MATLAB. I mean, one of the powers of MATLAB is all of these pre-built or built-in functions that it has, okay, for each one of these toolboxes, right? So for example, if you work with C, if I want to read an image and show that image, and I'm not using libraries like OpenCV and so on, it is going to be a very arduous work to just simply show an image, right? Read and show an image from the folder, right? In MATLAB, all you need to do is to simply use the command imread to read the image, and then imshow to what? To show the image. Okay, so they are very, very simple, because behind imshow and imread there is a lot of code that somebody already wrote for you, and you don't have to bother going through every detail of that. So these built-in functions are amazing in MATLAB. But for every application that you have, you might not find a function already written for you, but some people who are really enthusiastic about MATLAB, they have created lots of extra files and functions to perform different tasks that might not exist in MATLAB by default. So you just go to MathWorks File Exchange. Okay, and here is where you can see lots of different functions that people have written, even toolboxes and so many other things for you to just download and use. As long as you have an account in MathWorks, which is free to create, you can go and download the file. So for example, let's say text to speech, okay? There are several things, right, that people have written, functions, and you can see these are the functions that they have written. It's called TTS, and you just pass to it a text, some voice, pace, the number of frames per second, or the frequency here, And as long as you can download it, you can easily use this amazing thing, and you do not need to write anything on your own, and you do not have this function already available in MATLAB. Okay, so these are important. Now, plots, as I said, is quite similar to Excel, so we'll talk about plots in separate videos, and apps too. Okay, so today we're going to talk about the important commands that you need to use in the command window or later in a script or a function to do some basic communications and basic jobs done. So far I only told you about clear screen, about clearing the workspace, correct? And I want to tell you a few other things. So sometimes before you clean up the workspace, all the memory, the current memory, you might need to save that data somewhere, right? So let's say I made some of these variables that I already did, like that, correct? And before I clean up workspace and command window and start a new task, I would like to save these memories to a file, so later if I want to get access to them again or basically use them, I can. So what I will do is to use the command save. If I simply say save, that's the same job as here, it says save workspace. It will save all of these variables to a binary MATLAB file, which is called .mat. So whenever in MATLAB you see a file extension .mat, means it is a binary MATLAB file. It's not something like a text file that you can simply double click and open and see. Okay, it's a binary. Okay, so when you open it with the text editor, you're going to see some ambiguous, crazy combination of letters, shapes, and so on. If you say simply save and enter, all of these three variables are saved to a file which by default is called matlab.mat. And if you go here, you can see it. It is saved to the current folder, which for me is downloads. And this matlab.mat involves these three ABC variables. So now if I clean up, right, those ABCs are gone from the workspace, but I can bring them back, right? This is that for, and I can import the data from that, or I can use the command load. So if I say import data and I select the mat file, then it should bring for me A, B, and C back to the workspace. And you're going to see that, right? So it gives you this. It says, okay, create variables matching these names. Yes. If you want to exclude any of them, you simply say, well, maybe I don't need C. So uncheck that and say finish. And you only would get A and B back, right? So that's another thing to do. Or you can use the command load to load it. Now, let me show you that one. So if you remember, when I say save, it saved it to a file with the default name of MATLAB. If you don't like that name and you want to use a different name, correct? So let me just create one variable, C. If you want to save C to a different mat file, then what do? I say save, and then I provide the name. I say maybe my file or my data file .mat. Now that everything in the workspace will be saved to that file. By the way, let me make another variable too. Let's say this is equal to pi. So pi in MATLAB is a reserved keyword. When you say pi in MATLAB, that's exactly 3.1415 and so on. Okay, so here I create another variable, and I do not need to enter immediately, and then in the next cursor line, I type my next command. I can simply separate these commands by a comma or a semicolon, and what? And enter, and then both of them would run after each other. So not only D is created, now C and D should have been saved to this file, mydatafile.mat, and you can see that's here. So now if I say clear or clear all, and I go and import them, I should be able to see C and D here. Now, as I said, you can either import it here or you can say load and then say what? My data file dot mat. Load that file for me. And there we go. You got your C and D back. Okay? Now, when you save and load, you also have the option of not saving the entire workspace to that file. So if I want to save, correct, here, I want to save, but not both C and D to a file. Maybe I call it my data file 1.mat. I don't want to save both of them. I only want to save what? Variable C. So I put C inside single quotations, say only save C to this file called my data file 1.mat. And boom. Now you have a new file, and this one only has C in it, okay? So if I just clean up and load this file this time, it should only have C. Okay, so you can be choosy about which variables to save or to load. Okay, so this is communicating between workspace and external files, okay, .mat. And as I said, if I go to my .mat files, any of them, doesn't matter here, I right click and say open, and I open it with the text editor, correct? You're not going to see something nice that you can easily decipher. You clearly see that here, right? So if you look, these are those variables A, B, C, and so on. And you clearly see because it's definitely encoded. It's binary coded, and you cannot see clear C equal 4.3 and so on and so forth. Okay, so .mat is a binary file. Okay, so that's about workspace and variables. Now, what about these commands that I used in the command window, right? You see, I have used a bunch of commands. Is there any way that I can also save these commands that I typed in the command window align with the result of running those commands? So for example, when I say C equal hello world, not only it creates this variable C for me, but let's say C or maybe E or whatever, txt is equal to MATLAB is fun, correct? When I do that, now the result of execution of the command is also shown on the command window. So can I save the command I used and any possible result on the command window? Can I save those to some file? This time, not a binary file, a text file. Can I? Yes. The command to save everything you type on the command window and the result is called diary. And diary, all you need is to provide after it a file name. So I say my commands. Okay? And when you say that, from this point on, not prior to this, from this point on, whatever you type will be saved to a text file called my commands. You see clearly it is created here, and now let's say I type this again, say text equal MATLAB is fun. Now, if at the end of any line of command you add a semicolon, the command still will run. If there is a variable, it will be saved to the workspace, but the result of the execution is going to be suppressed. When, look, I clicked here, the variable is generated, right? Let's say I want to clean that variable. By the way, you can clean specific variables and not the whole workspace. If you say clear or clear all, it gets rid of all variables in the workspace. But if I want to only get rid of text, I say clear only variable text, right? So look, when I run this command again, but I use a semicolon at the end and I enter, The variable is created, so means the command is executed, but the result of that, which showing here, look, showing this on the command window is suppressed. Good. So now let's say I have done some commands. Some of them I can see or cannot see the result depending on whether I use the semicolon or not. And I'm done. Now I basically close that text file and say don't keep writing to it anymore. So I say diary off. Don't write anything more to it. Turn it off. And now this file here, if I go again under my downloads, I should be able to find that. And I should be able to open it with the text editor. And you clearly can see everything between when I call diary and the file name and diary off, everything is stored here, but nothing afterwards. Okay, so this is to store your command window and whatever happened to it. Now, I remember in one of my classes, one of my students asked an interesting thing. Said, okay, you can clean up the workspace, you can clean up the screen. Can you clean up the command window, the command history? You see here, I have a huge log of everything I did. Can you clean this? And the answer is the command for it is not as simple. What you need to do is a long line which comes from basically a something on MathWorks website. So you need to type in this com.mathwork.ml services.ml command history services remove all. You have to literally type this guy, and now you see when I use up and down arrow, it says no command recorded. It's all gone. So if you want to clean up command history, that's a little bit harder. There is also a Control-C, which we'll talk about later. That's when you're running a code or something, and you want to stop the execution of that because the code takes some time. And in the middle of running the code, you found that, hey, somewhere I made a mistake, and I don't want to wait several minutes or hours before the code ends, and then I go and fix the mistake and run it again. I want to stop it right now, fix it, and run it with the correct code. Can I do that? Yes. To stop the execution, you first use Control-C and stop it, do whatever you want, and run it again. Okay, so that's Control-C. Now, let's talk a little bit about naming the variables. So here you saw me, I typed some names for variables A, B, C, so on. But first of all, what kind of names can I choose for variables, and what's a good professional way to name the variables? So first of all, variables in MATLAB can only be a combination of letters, numbers, and underscore. That's all you can do. Okay, so this is a valid variable name. Now, can I, and it doesn't pick on you if you made it capital letters, that's fine. Indeed, even MATLAB is a case-sensitive language. So for MATLAB, if you say A equal 4 and you say cap A equal 2, cap A and small a are two different variables. Okay, so MATLAB is case-sensitive. Now, the good thing about MATLAB naming, creating variable is when you define a variable, unlike C or Python, you do not need to declare the type of the variable. You do not need to say, hey, this is an integer, or this is a double, or a floating format, or a character, or whatever. MATLAB will find the type of it and allocate enough memory to store it. So you do not need to mess up with that, okay? For some people it's an advantage, for some people it's not. But you do not need to declare the type, okay? What else? As I said, any combination of letters, numbers, and underscore. Anything else is not allowed. So you cannot say A-2. This is not a name. Can say a underscore 2 or a2, but dash is not accepted. Plus, special characters, dollar, @, any of these, okay, is not accepted. Now, what can you start with? So a2 or a1 is a variable name, right? You can say a1 is 12. Now, can I say 1a? Can I start the name of my variable with a number instead of a letter? No. It says invalid expression. I do not like you to start the name of a variable with what? With a number. Can I start it with underscore? No. So if you want to start the name of a variable, you better start with a letter. After that, it doesn't matter any combination of letters, numbers, and underscore. But you start with a letter, okay? Now, many people, when they define variables, they would rather, first of all, have meaningful names to the variable. So if you have a variable that represents what? Let's say speed, they are not going to call it A. They probably either use S for speed, or they maybe use directly the word speed, okay, or kind of make it a little bit shorter, maybe SPD or something. Okay, so try to have meaningful names, not just A, B, C, because your code should be understandable for other people. And one other thing that we'll talk about later, to make your code readable to other people and understandable, you have to add comments and have enough of comments and descriptions for your code. But anyways, try to use meaningful names. Many people would prefer you to start, the professionals, to start the name of your variables with a capital letter and then followed by small letters. Okay, so they do not start everything with the small letter. But it's not mandatory, really. It's just a convention between most of the professional programmers. Another thing, some words, some names are reserved for MATLAB specific keywords and functions, and you should not use them. Like what? Like, remember A and S? When I type something in MATLAB and I do not assign it to a variable, you see here I'm saying 3 times 5. I'm not assigning it to a variable and say A equals that. I just say 3 times 5. MATLAB will assign the result of that to a temporary variable called A and S. You see here? And I can use this A and S. So I can say A and S plus 4. What do you think? Yes, I will get 19. But now this A and S has changed. While if I just called this 3 times 5A, and I said A plus 5, I would get 19, but my A would stay 15. It's not going to change. But here, this A and S, every time you do not assign something to a variable, the value of this guy keeps changing. And this A and S is a reserved keyword, so it's not a good idea when you want to create a new variable to say A and S equals 6. Don't do that. It's a reserved keyword. What else? I and F. In MATLAB, it stands for infinity, okay? And we are not going to name any variable like that. Remember, I told you about pi. Pi in MATLAB is what? 3.1416 or 1.1592. Here, I'm only showing it with 4 decimals. Okay, that's a reserved keyword. Epsilon, EPS. Epsilon is something times 10 to the negative 16, specifically 2.2204. What is epsilon? Epsilon is the smallest number MATLAB can keep track of and has any meaning to MATLAB when doing arithmetic. Any number smaller than this literally means 0 to MATLAB. What do I mean by that? I mean, let's say here, A is 4, right? If I add A to epsilon, what do you think would happen? Is it going to be 4 plus this number? No. The result is going to be what? Here, 4. You see? Adding this number to 4 has no effect because to MATLAB, this number and numbers smaller than that literally means they mean 0. Now you might say, well, how do I know? Here you're only showing me 4 decimals. Could you show me more decimals? Yes. If you want to see more decimals in MATLAB, this format of displaying numbers, default of MATLAB, is called format short, 4 decimals. If you want to see more decimals, you say in MATLAB first, format long. Now if you say pi, you see now a lot more decimals. Exactly how many? As you can see, there are 15 of them. Okay, so now when I say epsilon, you see this number, correct? And when I say 4 plus epsilon, you see, I'm using 15 decimals. Look, there is nothing added after 4. So again, this number and smaller than that means 0, and it's a reserved keyword. Do not use it. Also, although you can use I and J in MATLAB to give the name to some variables, and I see that quite frequently, my students use I and J for a loop counter. I recommend not to use I and J for loop counters and instead use I, or JJ if you want, because I and J are reserved for the complex spaces. So when you say I squared in MATLAB is what? -1, the same thing for J. J also the same as I. It's also -1, okay? I know people in electrical engineering, they use J more than I for basis of complex, because I for them stands for electric or current, okay? So I can say 3 plus 5 times I, right? That's a variable I can call B, and I can say C is also 3 plus 5 times J. It's plus actually. Okay, so I and J are the base of complex. You can exceptionally use this to say, hey, I want I to be 4 or 3. You can, but not a good idea. The other thing are functions, built-in functions. For example, in MATLAB, command squirt is a square root. So if you say square root of 9, the answer is 3. So now I'm not going to call a new variable squared. Say squared equals 5.4. No, don't do that. Built-in MATLAB functions, the name of them should never be used as the name of any variable. Okay? So here I talked about format short, format long, naming variables. Now if you want to go back and not show all of this 15 decimals again, just say format short. And now if you say pi, you should go back to 4 decimals. Okay, so these are important things about variables. Now, a few other important things about basic commands, important commands that you need to know. One of them is the command VPA. VPA is a variable precision. And because you saw, I could show you 4 decimals or 15 decimals. You might say, what if I want to see something with 10 decimals? Can I still do that? Yes. The command to do is called VPA. If you don't know how to use a command, don't panic. Just in MATLAB help, go and say what? Simply say VPA. Type the name of the command, and it brings you the help document for it, and how to use it and what it does for you. The way that you can write a command and use it, we call in MATLAB and in many other languages, we call it syntax. The syntax, the way to communicate to a command, is easily found under help. Okay, so it says uses variable precision arithmetic, correct? And if you say VPA of X or VPA of X and D, the default is 32 digits. But if you say VPA of a number and maybe 10, it should show you with 10 digits. Or if you say with 6, it should show it with 6 digits. Okay? And the thing is, what the variable you have to pass to it should be symbolic input. Okay, so here if I say VPA of pi and 8 digits, you see, since symbolic toolbox in MATLAB recognizes P, it doesn't pick on you. And say, here we go. Here are your 8 digits. By the way, it's 8 digits, not 8 decimals. Okay, because 3 here counts as one of those digits. So if you want really 8 decimals, you have to say 9 digits. Okay, so we'll talk more about VPA when we later talk about symbolic toolbox. But anyways, you can do that. Now, some basic arithmetic in MATLAB, you know, when you want to add numbers, it's simply plus, negative is minus, or dash, you have star or asterisk for plus, for multiplication, and slash for division, right? Now, one thing about the division, if I say 4 divided by 2, I get 2. Sometimes you might do a mistake and instead of forward the slash, use backward the slash, like this. Say 4 backward the slash 2. Look at the result. It's half. So this backward is, instead of dividing 4 by 2, it divides 2 by 4. So we call it backward division or backward slash. Okay, so keep that in mind. For power, we use the caret, correct? So you can say 3 to the power 4. And what else? There are lots of important basic functions that you need to know. I showed you the square function, correct? That's the square root. So you can take the square root of anything you want here. But there are a lot more functions. One of them is the sine, cosine, and tangent functions, okay? Or cotangent function. These are the basic symbolic, the basic harmonic functions. And here, let's say I want to calculate sine. And I say, what is sine of 30? Well, based on your trigonometry, you know sine of 30 is what? 1/2, correct? But here, when you type the number here, you will be surprised. Look, it's almost -1. You say, what's going on here? Sine of 30 is -1? Yes, because you have to pay attention. Whenever you use sine, cosine, tangent, and so on, the inputs that you put inside the parentheses is in radians, not degrees. So this 30 is 30 radians, not 30 degrees. If you want to use degrees, there are 2 ways. You either convert that 30 degrees into radians, so you say 30 times pi divided by 180, correct? Convert your degrees into radians. Or there is a simpler version of that. There is a built-in command in MATLAB called sine d, and d means degrees. So now if you say sine d of 30, boom, that's half. Okay, or cosine d of 60, that's also what? That's also half. And tangent d, right? Tangent d of 45, that's 1. But tangent of 45, don't expect 1. It's not going to be. It's 45 radians. Okay, so pay attention that when you have d, they are in degrees. When you have when you don't have d, it's in radians. You also have inverse trigonometry functions like a sine. It's not arc sine, it's a sine. And when you say a sine of 1, again, do not expect it to give you 90 degrees. It's not gonna do that. It does, but it is in what? In radians again. This number, if you convert it to what? To degrees, so multiplied by 180 divided by pi, you should get what? 90 degrees. But the output of a sine, a cosine, a tangent, these are all what? In radians. If you want the answer to be back to you in degrees, use a sine again, what? D. Now it directly gives you in degrees. Okay? So all of the harmonic and inverse harmonic functions, if you put a d in front of them, they return it in degrees or accept it in degrees. There is one other a-tangent function in MATLAB that we use a lot, especially in robotics. It's called a-tan2. A-tan2, what it accepts is not the ratio of sine over cosine or y over x. It's not going to do that. Okay, so in the unit circle, the ratio of sine over cosine, you're not going to pass to it. What you do, you pass to it y and x. And that's what we call this arctangent. We call it quadrant corrected tangent. Because, I mean, like, if you pass what? To arctangent command, -1. What angle has tangent of -1? Well, one of it is -pi/4. But is that the only angle? Clearly not. You know, in the unit circle, one of the angles with tangent of -1 is -pi/4. The other one is what? 3pi/4, correct? So how do I know which one? One of them is quadrant 2. The other one is in quadrant 4. This is in quadrant 4. So what about quadrant 2? This does not recognize that. But if instead of the ratio of y over x, you pass to it the sine and the cosine, or y and x, both, then it knows which quadrant. So if you say, for example, the sine is positive and the cosine is negative, correct? So this first one is y, or sine. So you say sine of the angle is what? Let's say square root 2/2. But the cosine is negative square root 2/2. Okay? Let's see. Oh, 8 and 2. I'm sorry. You see now this angle that it passes to you, this is 3pi/4, and I can show you here. You see? But if I change that and I say, well, no, the sine was negative, or y was negative, x was positive, now it gives you -pi/4, or -45 degrees. So this one is called a quadrant corrected or adjusted arctangent, and many applications we use this one. There are other functions that you need to know in MATLAB. Exponential. So if you want to raise the Euler number to anything, you use the exponential. So exponential of 1 is, of course, e to the power 1, correct? So that's e to the power 1, or the Euler number, which is 2.7183. But exponential of any other number you can create. The opposite of that is the logarithm function. Now, there is, when you say log in MATLAB, that's the built-in function. Log here in MATLAB is equal to natural log. Okay, so when you say log of 10, do not expect it to give you 1. It is going to be how much power this number needs to be raised to make it 10. If Euler number is raised to this power 2.3, it should give you what? 10. And that's the rounding error. Okay, but log in MATLAB is natural log. What if you really want log of 10 or log of 5? Well, if you want log 10, the MATLAB command is log 10 of 10. Now you get 1. Can I get other logs? Sure. Do I have log 2? Let's find out. Yes. So I can get log 2. Do I have log 7? No. MATLAB cannot give you log of every number you can imagine. So what if I really want log of something to the base of 7? That's where you use the natural log. So you say log of 10 divided by log of what? 7. And this means equal to what? Log 7 of number 10. Log of 10 to the base of 7, you can calculate it by dividing log of 10 divided by log of natural log 10 divided by natural log 7, correct? That's what you get. And you can check it by other numbers too, right? So let's say 49. You know, log of 49 to the base of 7 is 2. And here, you see, I can just divide their natural logs. Okay, so that's about log 10, log 2, and so on. There are also hyperbolic functions. Sine hyperbolic of x, okay, which, as you know, it's not really a harmonic function. It's a combination of exponentials. So that is exponentials of x, correct? Minus exponential of negative x and divided by 2. That's the definition of sine hyperbolic. So if you pass 0 to it, what do you expect? It's 1 minus 1 divided by 2, so you should get a 0. And you will. Okay, but if you pass to it, let's say, what? Pi over 6, which is 30 degrees, do not, of course, expect something like half or so, correct? Because it's exponential. You also have cosine hyperbolic of x, which, as you know, it is equal to exponential of x plus exponential of negative x divided by 2. So if you pass 0.0 to it, it should be 1, and it is. But again, if you pass to it, let's say pi over 3, don't expect the half. Okay, and we have tangent hyperbolic, and we have their inverses as well. A sine hyperbolic. So you have this function as well if you want. What else do we have? We have the absolute value, which you all know. So absolute value of -4, absolute value of a +4. We have the sine function. Sine of 4 is 1. Sine of -4 is what? -1. And sine of 0 is 0. So this function returns 1, -1, or 0, depending on the sign of your number. Okay, so sine, ABS. We have the function modulus. That is a very good function. So if you divide 10 by 4, what's the remainder of the division? Correct? Modulus, that's 2. If the modulus of one number and another number is 0, means that number is divisible by the other one. Okay, so we have the modulus. And then for converting floating precision to integer numbers, there are several functions: round, floor, ceiling, and fix. And each one of them is different. So let me tell you those. So if I say, what is round of 4.3? It says it's 4. If I say, what is round of 4.8? It is 5, right? You know rounding. It's above 0.5, it's the next number. Below 0.5, it's the previous number. But if I say fix, instead of round, I use the command fix. Look, fix of 4.8 is 4, fix of 4.2 is 4. So fix is truncation. Fix throws away the decimal. Round considers where the decimal is compared to 0.5. We also have ceiling and floor. Ceiling always returns the next integer, the integer that is bigger than your number, regardless of how much your decimal is. So ceiling of 4.3 is 5, ceiling of 4.9 is also 5. And the opposite of that is called floor. Floor returns the smaller integer compared to the number, regardless of how much the decimal is. Okay, so we have 4 different ways to convert your floating decimals into integers. Each one is doing a separate job. Okay, so I guess I have covered a bunch of important topics for you. Okay, so let's stop the video right now, and I will see you in our next lecture. Thank you for your attention.